Right, what we're going to go over then is this question. If you've got any questions at any point, please just shout. Use the trapezoidal rule with 6 sub-intervals to estimate the area between f of x equals the square root of 6 minus x squared from the values 1 to 2. Now, the first thing I'd want to do is think about how this question's different to the other ones we've done. In the other questions we have done in the previous video, it gave us what the jumps were. But in this particular question, we need to work out what we are jumping up in to get from 1 to 2. Now, like in the sequence topic, we can manually work this out through guesswork. We could say this is 1 jump, 2, 3, 4, 5, 6. And the reason why we're jumping 6 times is because it says there are 6 sub-intervals. You can see this in the answer. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the first thing you have to be able to do is to work out what this sub-interval jump is going to be. Now, this here says that h is equal to b minus a over n. This is what we call the jump in the sub-intervals. So this, if we work out h, that will tell us what we're jumping up in each time. In the video questions, h was always 1. H is now going to differ. This is more like a real life exam question. So, to work out h, you get b and a, and you substitute this into the formula. B is the biggest number, A is the smallest number, so we know it's between 2 and 1, these two numbers, divided by n, and that's how many intervals we've got. There's 6 sub-intervals, so we put it divided by 6, so this equals 1/6. So effectively, what we need to do is work out what the length is at 1, 1 and 1/6, 1 and 1/3, 1 and a half, 1 and 2/3, 1 and 5/6, and 2. And what we're going to do is, rather than manually do it, I'm going to show you how to do it on the calculator. Has anyone got any questions so far? No, great. Is this making sense? Yes, no, or not really?
Yeah.
Excellent. I'm going to go through this slowly. I did do this topic when I was your age, but I've not seen it since. So,
what are the intervals? 6 sub-intervals.
So, what it means by 6 sub-intervals means that there's going to be 6 jumps to get to from 1 to 2. Do you understand that part, first of all?
Okay, but it means that you need 6 jumps from 1x, like from x equals 1 to x equals 2.
Yes, and
okay.
We need to, in this question, which is why it's different to the previous questions, work out what the jump is. The jump is 1/6 because we use this formula, h equals b minus a over n, where you do the biggest minus the smallest divided by how many jumps there are, and then that will give you what you're jumping up in each time. If you don't like this formula, you could just do it with a picture and so kind of trial and error. But this formula is given to you, but they don't define what h, b, and a and n mean. So the formula is useful, but you've got to really understand how it works. Now, we need to be able to do it on the calculator. And I'm going to show you how to do it on the calculator. Please, can you all follow along? Yeah. We are going to get the calculator up. And the first thing we're going to do on the calculator is type in the y equals button. In the y equals button, we are going to put the function. The function is the square root of 6 minus x squared. Can we all do that now? The square root is second x squared. This is the x squared here. And then we're going to put in the function 6 minus x squared. 6 big minus x to the power of 2. Now, unlike in the first video, this second video and this second bit of teaching, I'm going to show you how to use this in the table. So, what we want to do is we want to change the table. Are you able to view what I'm doing okay at the moment? I'm going to rub this off because this is just getting in the way, I think. Let me know if you'd like me to do anything different. I'm trying to film, teach live and teach in person. So what we are then going to do is we're going to look at the table set. We've done this in sequences. We've done this in functions. So we press second window. And we want the table to start at what number? Gwendolyn, what do we want the table to start at? Gwendolyn, are you there?
Yeah, I am, miss.
1, miss?
1. Gwendolyn, do you agree that we want the table to start at 1?
I guess.
Okay, just to recap, Gwendolyn, this is between 1 and 2.
Yeah, I know.
Does that make sense why we're starting at 1?
Yeah, it does.
Excellent. And what's the table going to be going up in orally? If we're starting at 1, we've decided that this is our h value. What is it going to be going up in each time?
1.
Okay, so our table doesn't go up in ones. Just to check the answer here, what's it going up in? 1, 1 and 1/6, 1 and 1/3, 1 and 1/2, 1 and 2/3. What are we jumping up in each time?
1/6.
1/6. And how did we calculate that 1/6?
Well, we calculated already.
We calculated it already. So then we go back to the calculator. We say it starts at 1. It's going to be going up in 1/6. So you type in 1 divided by 6. Lovely. And then we want to view the table. Ben, can you remember how you view the table on the calculator? What do we press?
To view the table, is it not just second table?
Second graph, excellent. So here is our table. So our table looks like this. 1, 2.2361, 1.1667, and what we want to focus on is these blue generated values between the 1 and the 2. And you'll see that those values are the same as given in this question here. So once you've got those up, sorry, I've just had a connection problem. Can you all make sure you're at that stage where you've got that table on your calculator? Does anyone need any more support with this? This is a bit challenging, isn't it, in some ways? Right, I'm trying to connect to the display and it's just decided to turn off. Obviously a very old teacher. I'll be with you in about 30 seconds once I get the connection working again. Okay, so we've got this table. So what we say is that when x is 1, our generated value from the substitution is going to be 2.236. When x is 1 and 1/6, our substituted value is going to be 2.153. Has anyone got any questions so far? Please ask. I'm accepting that as a no. So what we then need to do is you grab the formula. Now the formula is given to you in the exam like this. 1/2 brackets of the first plus the last, then plus 2 of everything else. And I'll show you how this works in practice. So we have 1/2 h. We've worked out h, brackets. The first value we generated, which is 2.23, 2.236068, plus the last one, which is 1.414214. This is why it's got x of 0 and x of 6, because this is the first value and this is the sixth value. They just include a column saying this is going to be the first one. We'll label it as 0 to 6. You don't really need to understand this column. What I would understand is the fact we're doing 1/2 times h of the first plus the last plus 2 of everything else. So this is the first, we've used that one. This is the last, we've used this one. Plus 2 of everything else is these final values. Now, if you can't be bothered to write this in the exam, what you can do is you can put plus ... Or you can do a couple of the values and then you say, we've done this one plus ... So we're going to add all of these together and then plus the last one, which is 1.624466. What you have got to be careful in the exam is that you put the brackets in the correct place. So if you're not very good at putting it all in your calculator all at once, you might want to put it in sections at a time. You might want to first of all work out the 1/2 of the h. Then the next section you might want to work out the 2 times. And then the next bit you might want to work out the first and the last added together. And that is effectively the trapezium rule. The video explains why it works, but if you don't want to understand why, just remember it's this formula. Has anyone got any questions? Can you put in the chat box whether you're feeling happy, sad or okay, please?